Okay, Professor Russo, can you hear me?
Dottor Corrado, mi scusi se un attimo rimango in italiano. Siamo pronti per iniziare in aula?
Sì, in aula siamo pronti.
Perfetto. Ok. Quindi possiamo iniziare, dico, non abbiamo...
Sì, può aprire la
Devo iniziare puntuale. Perfetto. Okay, so hello everyone. I am Antonio Russo, the chair of this session. This is the second session related to the Maintain workshop. Maintain is a workshop about transportation system modeling, risk management, and other urban mobility related problems. And this session will feature 5 presentations. Each of them have 15 minutes available, considering also time about question and answers. And these 5 presentations, this is the second sessions of the Maintain workshop. First one was this morning at 8 of Eastern European time. And so I would like to invite Dr. Domenico Sgro, which will present the first contribution of which title is Risk Reduction by Evacuation in Transportation System, Survey and Descriptive Results with Technology Acceptance Model, TAM. And this presentation will be performed in present as indicated in the chat. So thank you, Domenico. The floor is yours.
Thank you, Chairman. We can start to share the presentation. Thank you. Hello, everyone. I am Domenico Sgro, a PhD student from the University of Reggio Calabria in Italy. Today, I am going to talk to you about the risk reduction by means of evacuation and the context of mobility. Why this work? Because of this number, 387 natural disasters all around the world. This is a huge number, and this is growing during last year. So this exists a sustainability problem from different points of view, as well as you can work at a plan and publish it, but you are not sure that people will understand it and will follow it. About these reasons, we report and propose in this slide a general approach in an emergency situation, and in particular, we are focusing on the action before the disastrous events, in particular about evacuation and exercise. After this preliminary considerations, arise these two research questions, important research questions. It is possible and how to support emergency exercise with the contribution of technology acceptance models, TAM, because until now this paradigm is used in other situations, but never try to combine the word of TSM, transportation system models, risk reduction, and TAM, and consequently how to perform a pilot survey in that situation. After this background individuation, we can propose a table of contents or outline. The next section contains the proposed framework. In particular, we can underline some general definition. It is well known the definition of transport risk analysis, and in particular the 3 components. And I'd like to underline that we are working on the exposure component of risk. And in addition, you all know the traditional types of survey, in particular revealed preferences and stated preferences. But also today we are proposing another step in this research perspective, that is the TAM approach. It's composed by two main variables that are the perceived usefulness and the perceived ease of use. And in this section of the survey, we are trying to translate the definition in several questions, and so a set of data. Like I said, we are focused on the exposure component, and in particular, we are trying to perform an exercise by means of a survey that is a combination of the traditional survey LP and SP with a section of some questions. This is a general statement of the proposed framework with the focusing on the time section. This is a section of the question, okay, with several questions, and the answering method is score defined in a Likert scale from 1 to 5, so from disagree to strongly agree. Particularly today, I'd like to talk to you about a specific part of the survey. The other part was explained in other presentation on this conference. Today I'm talking to you about the analysis of the collected data, and in particular specific contribution of this research objective, that is the possibility of the identification of homogeneous group. But in what sense? In sense of question understanding by the users, attitude by the users, okay? And so we can specify the procedure that concern a tabletop exercise, which implies an evaluation planning scenario in which is submitted a survey with a TAM section. In particular, let's go into the main insight of this presentation that concerns the analysis of the collected data. It was performed with a statistical test, a T-student test, by means of the comparison of the average of different questions. Okay, the difference of the averages. On the left side, there is the specification starting from the score of the answer, the difference between the two scores, the standard deviation, so on, until the T-student test specification. It is important to underline the hypothesis. With hypothesis, we accept or reject the possibility to stay in the same group for the question. Okay, this is a general example of the two hypotheses. We performed a pilot survey. Why pilot? Because we wanted to explore the possibility to exist with research direction. So we needed this pilot survey. The perimeter of application is in the south of Italy. In particular, this survey was performed at the University of Reggio Calabria, that is in the south of Italy, as you can see. The questionnaire was submitted to a sample of people, of students, in last year, in April. It is crucial to underline that it is a discussion-based survey. So there were a person that helped and guide all the users to during the survey. Another assumption is that we are in a national emergency, and the emergency was activated, and the mode of transport considered in that situation was the private car. And also, in addition, the emergency scenario of the evacuation was two directions. in particular the north direction along the main highway, E45 or A2, and also the other suburban roads that go along the. This is an example of the emergency scenario. These junctions, this road is real, this scenario is simulated clearly, and you can see clearly the difference, the evolution of the congestion before and after an emergency scenario or after a disastrous event. This is the specification, the question design, in particular the time section. These are the contents of the question in particular. For example, we asked to example about the clarity of the plan procedures, the perceived benefits of the plan, the clarity of the information, the ease of following information. So if you remember the first two, the two components of TAM, we try to translate the POU and PU in these questions. Let's go in some results. This is the results of the statistical analysis. The sample was about 32 users. I remember that this is a pilot survey because we wanted to investigate the achievability of this proposed new method. So we needed this small samples. That the answer rate was clear. And like I said, the answer method was in a Likert scale. The score 1 is totally disagree, and the score 5 is totally agree. So we can see that for all questions, the sample was average in This is the result of the inferential analysis. I'd like to spend some time here because with 31 degree of freedom and 95% of significance and this critical value, we can observe that the achievability is verified because we identified 3 different groups. I remember that a group is a similarity of attitude of the users with the TAM paradigm. Okay, so we can see that there exists a group between the question A, B, C, and D, and no collinearity with the question E and F, but between E and F there exists collinearity. So E and F, we can say that are a group of questions, and the question G is related to all the other questions. That, if we remember, is an overall question. It's a transversal question. It is asked about the clarity of the information about all the plans. So this is a general, more general question. So in the right side we can say another translation of the result. We can also observe the strong collinearity between A, B, C, and D. The strong green means a strong collinearity, the light green lower collinearity, and red no collinearity. At the end, we can say that the achievability is verified. So, in the case of emergency exercise in a simulated context, it is possible to implement and put together the transportation system model and the technology acceptance models. Until today, it is not done. And also, it was possible to cluster the questions and in this way it's a similarity of altitude, and also has a possible research directions. We will extend the sample to obtain more insights, more results, more clear results. And also another research direction is the possibility to integrate the TAM with the random mobility models, okay? Inside the context of transportation system models or Bayesian network. This is all. Thank you.
So, okay, thank you, Domenico.
Thank you.
There are any questions? No questions from the audience? Okay, from online, there are some. Sorry, I'm hearing my voice.
No, there is no question. Not online and not on present.
Okay, not any questions. So I have only one.
Sorry.
The microphone. Maybe. Okay, thank you. So now I have only not the questions, more some information. Do you have, Dr. Sgro, some idea on how integrate technology acceptance model with random utility models? So you have highlighted this important point in the last slide, but can I ask if you have some idea on research direction, for example, in the possibility to integrate technology acceptance model with, for example, gender-related attribute, gender or other social demographic attribute, only this specification. Thank you.
Thank you for the question. That is the point of the research. That is just the cue. You get the cue. Yes, we are working on that. So we are trying different specifications, both on transportation system models or Bayesian networks. So we are working on that. We are using the attributes that you mentioned. So we are exploring this field, never explored. So we are trying to give an answer to this question in the next works.
Okay, thank you.
Okay, thank you. There is one question in the room. Maybe.
Yes. You mentioned at the beginning, in the first class, you mentioned there's a natural disaster.
Yes.
And there are, risks in the transportation. So can you describe what natural disaster means in the transportation field? What was the accident? What was right? So you have natural disaster and somehow related to transport risk. So how the natural disaster is a problem?
Yeah. For instance, I give you an example now. If you have a look to, this is Reggio Calabria, okay? This is a coastal city, okay? And so you can see the yellow line and the yellow hood and the purple hood. These are the crossing structures. We are nearby, beside the sea, beside the Strait of Messina, okay?
Yeah.
In that case, we can have flood disaster, earthquake disaster, okay? For example, in 1908, there were a big, huge earthquake disaster that destroyed the two cities of the Strait, Messina and Reggio Calabria. So in that case, it depends by the case, the risk, okay? In that case, we can have earthquake with a subsequent flood disaster. Okay. It depends by the the scenario, by the city, by the yeah, it depends. It is not always the same risk of disaster.
All right. Yes, the question is that this next, you're doing a kind of simulation or try to analyze this natural disaster and the effect of transportation. So what is what is this natural disaster and how that
In that case, a flood disaster, we consider a flood disaster. So the Q in this presentation is not the disaster, but it's the evacuation. The evacuation, okay? Yes, it's the evacuation. So the problem is the mobility. Okay, we have all these things that you are mentioning as a exogenous variable. Okay, for us. Because I'm a transport engineer. So for me, the disaster is an exogenous variable. I consider the disaster, I consider the capacity of the infrastructure, the reduction of the capacity of the infrastructure because of the disaster, but I consider the capacity, for instance, not the flood or the earthquake, because this is not my field of research. My field of research is the mobility and the analysis of evacuation, the exposure. In that case, like I said, is the exposure. This is the vulnerability, for instance. Thank you.
So if there are no any questions, we can go to the next presentation. So can I ask you to close the microphone? Okay, thank you. So the authors of next presentation are Antonio Comi, Ippolito Aidone, Marco Cortese, and Olesia Shkiekova from University of Rome Tor Vergata. Title of next presentation is Investigating the Choice of Receiving Online Purchases Through Discrete Choice Modeling Approach. I would like to invite presenter of this presentation, Dr. Olesia Shkiekova. Thank you, Olesia. The floor is yours.
Thank you for introduction. One moment. Let me know. Can you see my screen?
Are we seeing the presentation? Yes.
Can you hear me also?
Yes.
Okay, perfect. Thank you so much. So I would like to present you our research, and we go through 6 steps: introduction, motivation, state of the art, methodology, research and conclusions, and future development. So why is this research is important? Because we analyzed the innovative last mile delivery solutions. And nowadays we have more and more delivery channels, and for last mile delivery we understand the attributes that most influence the end consumer's choice of how to receive e-purchases, and simulate through the discrete choice model the end consumer's choice behavior. So in more details, we analyzed the literature review, understand that focus is on the end consumer and determination of influencing attributes. The third step is definition and development of the stated preference survey, then data analysis and choice model definition, and then conclusion and future developments. So as we know, in the management of the supply chain, is the last mile delivery is the last part of the transport from the hub to the final destination. In our case, we consider the way to end consumer. How do they want to receive? Last mile delivery represents an average 53% of the total costs of the deliveries within the city, and it's responsible for about 25% of urban congestions. That's why it's important to have more efficient last mile delivery system and more sustainable processes. Empirical studies have found that last-mile delivery vehicles have an average load factor of between 30 and 40%, with over 20% of vehicles traveling empty. Also, failure delivery are still a relevant transportation issue today, generating additional costs for logistics operators, inconvenience for end consumers, and increased impacts. Also, now we have more small and frequent deliveries. Also, the sprawled delivery, in geographical aspects. So, urban logistics has shown significant relevance around the world due to the numerous issues caused by the increase of freight flows within the cities. Also, e-commerce is growing worldwide, creating new transportation issues and pressuring to explore innovative approaches to address sustainable and livable changes. Current study aims to investigate the choice of receiving e-purchases because it can have a strong impact on the city sustainability. Based on the literature review, we can highlight the main trends. First one is focus on the growth of e-commerce, which causes transportation issues such as smaller, frequent, failed, and sprawled deliveries. The second one is focus on the impacts by freight vehicles movement during delivery process. And the third one, focus on end consumer requests, user-centric approach. Now they want fast, cheap, and more personalized delivery services, which we have to take into account. Thus, the end consumer's response to the innovative delivery channels has not yet received the scientific attention it deserved. And the purpose of the current study is to investigate how end consumers respond to innovations in last-mile delivery methods. Then we go through the methodology. Firstly, we identified main alternatives. First one is crowd shipping. It's hypothetical alternative. The crowd shipping represents a novel alternatives that utilize digital platforms to connect shipment demand with the supply side of ordinary someone willing to deviate from their route to deliver packages to end consumer, receiving modest compensation in return. So this is the main concept of crowd shipping. The next one is staffed pickup point and autonomous parcel locker. It's not hypothetical. It's implemented, but sometimes it's not efficient, or it might be changed to improve the efficiency and sustainability. Usually this alternative takes place in shops, cafes, or the post offices. Pickup point has opening hours and it's usually closed on weekends. It's place that the end consumer can choose in a convenient area, and the concept is a network that covers the city with high density. The autonomous parcel lockers are strategically placed in easily acceptable locations. It's shopping centers, gas stations, railway stations. It's like points of interest, and usually it's open 24 hours a day and 7 days a week. Why it's important? Because for end consumer, it's important to understand the time window when they can receive their e-purchase. So that's why I highlighted. Also, one of the interesting alternatives which we want to investigate is delivery to pocket car or into trunk. Now it's just a pilot version of this alternative, and the idea is that the courier or transporter reaching the car opens the trunk compartment with the secret code and leaves the e-purchase inside. Then the recipient receives a notification of successful delivery. This delivery channel already in use in not numerous cities, but it's in a pilot prototype, and introduce a new delivery point when end consumer don't need to have interesting in time window, because their car is parked during the working hours and in the office area, for example. And also, last but not least, staffed pickup points at autonomous parcel lockers. Oh, sorry, no, it's autonomous delivery drones. We include here sidewalk and also drones and consumer receives via application notifications related to their e-purchase from the moment it's assigned to the drone to when it arrives at their address. The use of drones promise extremely fast delivery times with a perspective of only 30 minutes. It's also hypothetically now, and in some cities in USA it's implemented, but in prototype stage because it's needed to have infrastructure, also needed rules from the government about the sidewalk usage, about the issues with pedestrians, and so on. So then we identified the attributes which characterized those alternatives. It's a delivery price. We have quite high range from 2 to 20 euros. Delivery time, delivery location, 0 meters, it means homes, within 20 meters, between 200 meters to 500 meters. So 3 levels. Customization, here we can choose the date and time of delivery possible, so time window and the flexibility. Then traceability, it's a possibility to track in main stages or track in real time. And level of sustainability, for simplifying for end consumers, we put eco-friendly vehicles or the usual light vehicles for delivery process. Then for methodology, we used the stated preference survey. It's a set of techniques that use statements provided by respondents to estimate their behavior in hypothetical context, because we have some of the alternatives hypothetical. Stated preference survey allow researchers to insert alternatives of choice currently unavailable. So then, because of numerous alternatives and attributes, we use the block breakdown. In most cases, the number of theoretically possible scenarios depending on the different factors and these service attributes. It's very high, and the project that considers all possible scenarios is called the complete factorial plan. A technique called block decomposition allows to limit the number of scenarios by dividing them into groups or blocks to be submitted to the different decision makers, ensuring the properties of comparison and orthogonality. So at the end, we launched the survey online in Italian language, and here we can see the example. We visualize it in a table where we can see the alternatives and attributes, and we use this methodology. Then we use the engine software. It's a specialized software used to generate efficient stated preference designs by optimizing choice sets based on the statistic criteria, the efficiency to improve the reliability of model estimates. The stated preference area has been developed through the 3 steps. So each respondent has been faced with questions. First block is a sample characterization. It's a gender, age, level of education, vehicle used for travel, and so on. Then their purchasing behavior, frequency of purchase, type of product they prefer to purchase online, delivery alternative usually used, impact of the return policy on the purchase, and stated preferred survey. The respondents are faced with the 9 hypothetical scenarios in which they are asked to choose one of the various delivery methods proposed. So at the end, we have 2 blocks. Each block consists of 9 scenarios. First block is 165 responses. And second block 145. At the end, we have 310 respondents. The results of the socioeconomical characteristics of the sample, we can see the gender is 45% are female, 55 male. Also, demographical affiliation, it's North Italy 15%, Central Italy 50%, and South of Italy 35% respondents. And also age, we can see the main share is from between 18 and 34 years old. Also, because they are more digital native, they use the online platforms, so the survey been launched online. For this group, it's easier to fill out the survey, and also they have purchase power, and that's why the focus on this group is also important. Also, the level of education, we have 38% has master degree, 3% are PhD, 26% graduated from high school, and 33% has a bachelor's degree. So we can then compare the level of education and their willingness to choose innovative alternatives. Vehicle used for travel, for shopping, we can see 72% use a car, and 5 and 2% use motorcycle. Other modes are more ecological. It's walking, public transport, bicycle, and electric scooters, but it's about 20% of the sample. Then we also analyzed the purchase frequency. We compare physical store or in-store and online store. Then we can see the everyday purchasers several times a week, one a week, less than once a week, and at least once a month, and rarely or never. Purchases in physical stores are usually made more frequently than once a month, but less than once a week. Most of the sample, it's 44% makes online purchases at least once a week, and several times and once a week. So we can compare the online and in-store shopping, and we can see the people, if we compare with like 10 years ago, the previous situation, now they are more willing to shop online. Also, we analyzed the main types of products they prefer to purchase. It's clothes and shoes, then electronic goods, household products, and so a few stationery products and healthcare and others. The next step is analyze the preferred time slot for receiving delivery. If we analyze the total sample, we can see that the preferred peak in early afternoon from 2 to 4 p.m. and late afternoon from 6 to 8 p.m. It's the lunchtime and after work. In more details, we analyzed their preferences, putting them to groups like students, employers, and retailers. So we can see the differences in the time slots and also differences in their choices. Also, one of the results is that online purchases are more convenient and have a wide range of the products. That's why respondents prefer online rather than in store. And then we analyzed that for students, it's important to avoid journey and time saving. For retired, it's important economic convenience and avoid journey. And for employers, economic convenience and time saving. Also, we can see that traditional mail have been chosen by 22% of respondents, then staffed pickup point and autonomous parcel lockers like 52%, crowd shipping 9%, autonomous delivery robots 2%, and delivery to parked car into the trunk 15% of the respondents. Then we use the NLogit software for the realization of the choice models. The 3 steps we come through its specification, calibration or estimation, and validation. During specification, we identify the definition of the mathematical structure of the model. In this study, we use multinomial logit model when the respondents consider alternatives without any correlation, so separately, like it's just separately simple decision tree. Then a calibration model beta coefficient estimation using maximum likelihood method, and validation, its ability of the model to reproduce the choices made by the sample. We compared with t-students and checked the ρ-square. At the end, we developed the multinomial logit model with different coefficients for each alternative, and also traditional male being the reference alternative. Then we can see the science, which is important, and negative for time, cost, distance, which is logically correct. Also, with positive sign is level of education, frequency of purchases, which is also logically because they increase the utility of the delivery channel. Then we consider delivery time, cost, distance of delivery from place of work or home or point of interest, tracking service, age of the respondents, then respondents' home area, respondents' education level, and frequency of online purchasing. Also, we can see that t-students is higher than the 1.96, which means the significance of the our parameters. Also, ρ-square is 0.44. Also, we developed the sensitivity analysis, which conducted to investigate how variation in model parameters can impact on consumer choice outputs. Here we took the alternatives parcel locker and pickup points and shift from the level of the distance between 2 to 500 meters and go to the delivery at the distance within 200 meters. So we took the lower level of the attributes and we obtained the results. So the probability of choosing delivery channel is increased. The main results of this, we can say these attributes has strong impact on the choice of the delivery channel, pickup points, and locker, which as expected sees its percentage of choice decreasing as the distance of the locker closer to the place of the points of interest. Also, this barrier could soon become an opportunity. Thanks to emerging technologies, delivery to a parked car into trunk could be the possible solution. Also, some results, for example, in the current e-commerce landscape, the flexibility of timetables become the protagonist. Innovation in delivery methods is rapidly adapting, offering a service that allows deliveries without time constraints and without attendance. Among the socio-economical variables selected, those that have the greatest impact on the choice of delivery mode are age. When age increases, users prefer traditional delivery over innovative delivery solutions. Education level, as the education level increases, the users' propensity to choose innovative delivery methods. Frequency of online purchasing, generally as the end consumers' frequency increases, their propensity for traditional delivery decreases. Also, we have some RODA heat. It's include other attributes and emphasize the levels which will provide input for the design of the stated preference survey. Develop a stated preference survey with the aim of investigating in consumers' preferences for last mile delivery alternatives. Increase the number of respondents, increase the number of questionnaires, as well as delivering the stated preference survey in European countries, and develop the forecasting model. Also, we would like to try the nested logic model, and so on. So thank you very much for your attention. Also, I would like to mention we have the ongoing stated preference survey, where we also put new alternatives and also want to investigate new, additional attributes which characterized the alternatives, and it's beyond the Europe. So if you can fill out, it will be so great. Thank you.
Thank you, Dr. Hiekova. So thank you for sharing your contribution about discrete choice modeling in last mile logistics, considering also innovative way to resell goods like pickup points. So there are any questions from the audience?
Yes, one.
There is one question. Okay, one question from Professor Tiziana Cabisi connected online.
Okay, is just like a curiosity. If you please underline the source from which you took the 6 different analyzed parameters, just like discussed previously. I don't understand well if you use a literature review, a single paper or other.
Thank you for your question. Yeah, sorry, I didn't mention this. Yeah, we took the attributes based on the literature review. Also, we combined them because sometimes we found the literature consists of, for example, price and distance to just compare two attributes. The levels of attributes we took also mainly from literature, but also, for example, if we go to the Amazon, we can see the more or less possible delivery price. So we combine it, and if you see in delivery price we have 6 levels, 2, 5. Maybe in the future it's better to decrease this number, for example 2, 10, just to point it's expensive or low or high price. Also, it was a little bit difficult because we have to fix what kind of product they purchase, because if it's expensive one, the traceability, the attributes might be different between expensive and cheap products. So yeah, we try to combine the literature review, more consider them.
It's clear. Thank you.
Thank you, Dr. Hiekova. If there are other questions from the audience, because I cannot see it. So, okay, a question from Professor Torau.
I can't hear.
We can hear. Sorry, we cannot hear.
Maybe try now.
Oh.
Yeah. Can you hear me now?
Yeah.
Yes.
It's all right. All I see. Thank you so much for this very interesting and engaging presentation. You showed a slide where you showed the motivations about this purchasing model choice, and it was stratified across student, retired, workers or employer. I find it very interesting. When it comes to future work, I would suggest for you to consider. So science do surveys analyzing for example, purchasing frequency. It will be interesting also to consider the income.
because according to the income, there is a likelihood that is going to impact the frequency of some purchase modes. In addition to that, it will also be interesting in the demographics to consider the gender effect, because there it was also a very interesting slide showing what are the most likely type of products. I would think that for a more in-depth analysis, stratifying those like products that the consumer is more tending to go by gender, because there will be most likely a difference between females and males in the purchase frequency, also in the type of products and state preferences, and also by age. So it will be really very, very interesting as future work also to consider the gender, the income, also together with the age. This is just a suggestion, but thank you so much for the presentation.
Thank you so much for suggesting. Yeah. I think it would be a great idea to investigate in further steps. Yeah. Thank you.
So, there are any other questions from the audience?
No, not from me.
Okay, thank you, Dr. Fiekova. We can go to the next presentation. The authors of the next presentation are Antonio Russo, Tiziana Campisi, Chiara Spadaro, Minato Rao, and Giovanni Tesoriere. Title of next presentation is Demand Responsive Transport and Social Exclusion Literature Review on Gender, Age, and Income Impact. Just to be directly connected with the previous questions, the presenter of the next presentation will be Professor Tiziana Campisi. So please, Professor, the floor is yours.
Good morning, everyone. Can you hear me? Can you see my screen?
From mom, yes.
Okay, thank you so much. Just like previously discussed, in accordance with some parameters in terms of gender gap and also social exclusion, I will try to share this first preliminary basin analysis related to demand responsive transport system linked to smarter fleets project. I just introduced the demand responsive transit service, including some valuable parameters and also characteristics in terms of flexibility, punctuality, and also in terms of efficiency. This type of transport mode could be defined like a complementary transport mode in terms of public transport, in accordance also to the some goals linked to Agenda 2030 in terms of sustainable development goals, and for special in terms of accessibility and also in terms of sustainability and gender gap. This transport mode is growing during the last decades, and this research tried to discover some main social demographic parameters that can determine and define some demands. In general, we can observe, and in this research, we investigated some attributes in terms of gender, age, and income, including a first preliminary literature review analyze in order to explore the qualitative and quantitative contribution and in accordance with a focus on modal choice model. And in particular, a systematic literature review was conducted, including the main academical search website. And this approach involved, in order to define some appropriate specific keywords in terms of inclusion or exclusion criteria, in terms of analysis for the particular selected studies. The results of this research determine a classification of the role of the three different attributes gender, age, and income. And the results shows that is a growing interest on demand form of mobility, and also some results will be discussed on the next slide in terms of each specific parameters. We can try to share the main scenarios of demand responsive transport development, including the concept of weak demand areas. Now and during the last pandemic event, we observed a different transport demand growth, and we explore also some newest concepts in terms of derived demand. It is important for more sustainable and flexible mobility to introduce also the concept of accessibility, including different cluster demands and the different reason of the travel. It is important to analyze some spatial and some social mobility, considering the different shape and the different space distribution, in accordance also with some gender inequalities in terms of different cities size and different type of society. And we decide to discover three of the main variables in terms of age, income, and gender, just like described on the next. We try to underline and we focus our first step of research, including these three main research question, and we will try to explore something in terms of DRT and social demographic attributes and the relative comparison. We also determine something in terms of spatial space distribution of the main academical work in different parts of the world. And also we will try with the final question something in order to introduce some key consideration that could be highlight the combination and the relationship of the adoption of the DRT with the three investigate variables. The main keywords and the keywords combination and Boolean operators that we used in order to explore literature review are presented on this slide. We try to combine the main and the common definition of demand responsive transit or on-demand services, combining with some specific words and keywords related to gender, age, and income. We explore some subsets of the literature records, including the items and relative relations, just like described on this table. We determine that the selected literature that are explored during the last 20 years includes and some classification year per year, and the temporal evolution, the temporal spread of the demand responsive transport research was determined and underlined through these trends defined by this graph. We understood and we can underline a good increase of the demand responsive transport research, especially after COVID pandemic, and also just like described by the exponential regression line rate, we can indicate the value of the R squared close to 1. And this can suggest and underline that there is a perfect exponential growth in the number of the paper publication. We explore also the literature review in terms of spatial analysis, analyze different countries that made or applied the demand responsive transport system. The highest number of the paper was found in the USA, followed by China and Canada. In terms of European countries, we can underline that there is a good combination and a big distribution in Germany, and also we can observe in the UK. The paper linked to the European plus UK are some like 17 papers, and they can underline the significant emphasis on these topics and include some social exclusion research in terms of European context. Here we can combine some results made by literature review, including the distribution of different parameters investigated, and also the combination on the second graph, in which we can determine the biggest percentage that could explore primarily age only. About our previous research question, we can determine that in terms of general trends, temporal distribution, and we can underline that the topic of demand-responsive transports includes a high level of interest in the recent year, and we underline it especially after pandemic situation. Probably about and considering the spread of the weak demand concept that cannot only consider the peripheral areas, but also the areas linked to the urban context, for example, or other in which there is a lack of transport modes. In terms of geographic distribution, we observed that the main literature review was made in USA and China, but there is a growing percentage also in European and United Kingdom, where the demand-responsive transport was developed in difference here. And we can observe also that in terms of the three main attributes, we can underline that a big percentage of the research or the literature review underline that demand-responsive transports are like our services planned for the elderly. But some studies underline a non-significant relationship from elderly people and the adoption of on-demand services. In this context, we can underline that different types of cluster group are growing and are growing the demand of different clusters in this context. In terms of gender, we can observe through literature review that in general, female show a greater preference for DRT, especially in terms of safety linked to general travel. And also in a second group of research paper, we explore that female prefer individual transportation option such as private car and taxis, for example, over DRT. We can also observe in terms of income a positive relationship between the spread of demand-responsive transit services and the greater opportunity for low-income users. In terms of the third question, in terms of thematic distribution, we can underline that there is a significant interest made by literature review in these attributes, gender, age, and income, and the interest in age and especially in general is significant. The research, this preliminary step of research can highlight that demand-responsive services can help to introduce better these concepts and introduce better some methodological approach that could combine these variables. And also the relationship between the willingness to use these services and gender is more complex. In fact, it depends on the context, and also DRT would see to be safer for women than public transport, for example. But it is important to consider the real perception as less safe than the private cars or others, such as taxis. And the results of this preliminary literature review can determine that reduce the reduction of inequalities and also to address better the phenomenon of social exclusion. These studies can propose some research question and can introduce better some basin for different stakeholders. The methodologies are not directly compared, and quantitative comparison between the attributes of the different transport choice is not proposed here, but is defined like the next step of future research and development of this research. In terms of stakeholder, we can underline that these studies could be probably a good base for research and academics that can determine in the future new review and new contribution in the terms of on-demand transport modes development, and also can consolidate some methodological approach and investigation of these parameters on this context. In terms of policymaker and also planner, this research can determine and can underline some critical issues, and we can observe and we can determine some good option for next urban planning and mobility in terms of complementary system, including, for example, public transport and demand-responsive transports, and also considering better some vulnerable condition of the transport user. I'm just finished my research presentation. Thank you for your attention.
Thank you, Professor Campisi, for your presentation. I would like to ask if from the room there are any questions, because I think actually I don't see the connection from the room. It is possible?
Yes, Antonio, I think you are right. The technical assistant was called in another presentation, so I am here just to support.
Okay.
I just have a question for Professor Tiziana Campisi. It was really a great presentation. We understand better now the state of the art. So Tiziana, how you see the direction for these studies that now, fortunately, they are really paying more attention to the gender, to the age, and the DRT, as a matter of fact, is being recognized as a very smart solution. What do you think that is the future research of DRT-related studies?
Yeah, we are working now with my research group, including these parameters, with the other, but especially including gender, income, and age, underlining better some methodological approach and some equation could be determined better this phenomenon and can include these transport modes, for example, including some logic model in terms of transport mode choice, and also discovering something of newest in accordance with this transport modes that are not singular transport modes, but are including in a biggest approach and combination with public transport system.
Very good. Thank you.
So, are there any other questions from the audience, from online? No. So I would like to ask Professor Torau that is following us from from Istanbul, if we can continue with next presentation, or maybe maybe do you need some minutes to fix the problems? I don't know.
Antonio, I really would like to help with that, but I would say, can we give it a go with the next presentation? And then we will see, could the speaker, because I don't know from here now, right now, how to support this, could the speaker share the screen, or does the system has some kind of settings that it will make it challenge? So I see Greg Fontes online.
Gregorius, I think Professor Fontes is online. I
Hello,
think
yes, I'm here. So I can share my screen, right?
We see you in, yes, in the video, but not yet.
Okay, so are you seeing us from the video? So if Professor Fontes share the screen, you can see the screen without any other problem. Okay, thank you. So let's go with the next presentation. Some, as usual, authors and title. So the authors of next presentation are Elisea Dimaki, Evangelia Anastasia Rapti, Vasilios Sitskos, Grigorios Fountas, and Socrates Basbas from Aristotle University of Thessaloniki. And the title of next presentation is The Role of Remote Activities in Urban Mobility in Post-COVID-19 Era. And I would like to invite the aforementioned Professor Fountas to share the screen and comment their contribution. Thank you, Professor.
Can you see my screen?
Yes, we do.
Yes.
Oh, excellent. Thank you. So thank you very much, Antonio. What you can see right now, can you see the entire screen or just the notes?
Now we are seeing the presenter mode. So yes,
that's the problem.
Yes, we see your notes.
Mm-hmm. Now it's better, right?
Perfect.
Excellent. Thank you very much. Thank you very much, Antonio. Thank you for the introduction. Thank you, everybody, for joining the session today. Yes, exactly. I will be presenting some insights from our latest study on the role of remote activities in urban mobility in the post-COVID-19 era. Of course, COVID-19 sounds like something very old in the past. However, I heard in the news yesterday that there is again an uptake, an increase in the cases in Europe over the last few weeks. But this is something quite old in the past, at least from a medical perspective. However, the impact and the consequences of COVID-19 are still here, in the sense that COVID-19 brought forth major changes in travel behavior, major changes in remote activities, in generally behavioral patterns. And one of these big changes that is still here, and we expect that it will remain, at least to some extent in the future, is the emergence and the establishment, actually, of remote activity patterns. In other words, remote activities such as work from home or teleworking, and education from home, like teleeducation, online shopping, and any other kind of remote activities. So we all have personal experience of working from home during the outbreak of the COVID-19 pandemics. However, now that, as I mentioned before, the pandemic is something quite old in the past, we still see that a considerable portion of employees and workers actually are still exercising the work from home model in their different kind of jobs. However, as we also saw during the COVID-19 pandemic, the emergence of the remote activity patterns also had some impact on travel behavior, on travel patterns, on mode choice. And this is exactly the focus of this study, where we don't want just to see the changes in the remote activity patterns before, during, and after the COVID-19, but we would like to see a bit in a combinatorial way the association between remote activity patterns and impact on urban mobility, especially. So we want to see the behavioral shifts before, during, and after the COVID-19 pandemic, and also we would like to see how these changes in behaviors, especially travel-related behaviors, may unfold in the future. The future is now, actually, because we have 2025. For our study, actually, we selected the city of Thessaloniki in Greece, where our university is also located, because, first of all, it's the second largest city in Greece, and secondly, it is an urban hub, a hub that over the last few years has attracted several tech companies, several startup companies, which is the ideal setting, right, for remote working. And also it is one of the cities in Greece with a very large, perhaps one of the largest communities across the country. I will not spend most of your time. I will go directly into the details of our study. So for this reason, we conducted a survey, a questionnaire-based survey, online survey actually, that ran between May and June 2023. The survey was our target population was the population of the city of Thessaloniki, but with particular focus on the academic community. So the sample was distributed in the academic community of Thessaloniki, but also we tried to expand the boundaries of the academic community, and using a snowballing sampling technique, we also sent the survey by email to a greater sample. The questionnaire underwent a rigorous ethical review, and it got approval from the relevant institution here in the university. We all, as I mentioned before, we employed an online questionnaire design, which we included approximately 30 close-ended questions. The survey was administered through the software of Lime Survey, which is also officially approved by the university, and in order to identify associations between the determinants of travel behavior post-pandemic and also the determinants of the remote activities post-pandemic, we conducted two levels of statistical analysis, descriptive analysis, and inferential statistical analysis. We also conducted some additional models, statistical models, discrete choice models, like the ones that we saw in the previous presentations, but we decided to include in this presentation mostly the findings of inferential statistics, in the sense that we didn't see any major differences between the models and the inferential tests. In terms of the structure of the questionnaire, we asked mostly questions about the mobility of people before, during, and after the pandemic, their mobility patterns, their travel habits. We also asked them about their patterns and experience with teleworking or any other kind of remote activities during the COVID-19, such as frequency, their attitudes, their perception about, and their experience about teleworking, but also what kind of challenges and benefits they saw in this new hybrid working and remote model. We also asked them to evaluate and to provide some predictions about the future trends, not only in terms of their travel habits, but also in terms of their remote patterns, remote activities. And of course, we concluded the survey with the usual and very important, essential information about the socio-demographic characteristics of the respondents. So just to give you a preliminary screening of our respondents, the majority of our respondents were female. As you will see, more than 60% were females, because mainly the survey was distributed to an academic community. The vast majority of the respondents were young. As you will see, almost 60% were less than 27 years old. And in the right-hand side of the slide, you can see, let's say, simplistic distribution in terms of mode choice of the sample across different time periods before, during, and after the COVID-19 pandemic. I forgot to say that we collected data from 1,115 respondents. As you will see in the graph, across all modes, we had a drastic reduction of use during the COVID-19 pandemic, and then after the pandemic, we returned to the almost more or less to the pre-pandemic level, especially for the use of car and for the use of city bus. We saw a slight increase post-pandemic in habits related to walking, actually. So people prefer slightly more walking after the pandemic. Perhaps the experience during the outbreak of the pandemic was quite influential to that change. We asked the respondents, if we go in more specific details, we asked the respondents about their future intentions of travel, and we asked them about their future intentions by different trip modes and by different trip purposes. So we will be starting with the intentions of travel by trip mode. So the question was formatted in a 5-point Likert scale, starting from much more, that I expect to use the specific mode much more in the future compared to now, and from much more to much less, right? So as you will see in the graph here, or approximately in almost all cases, in almost all modes, scooter, walking, electric bike, motorcycle, city bus, and car, we saw that a considerable proportion of people, they expect to use the mode at the same level in the future compared to before. But an encouraging finding was associated with the future use of walking. We saw that, let's say, almost more than 50% of the respondents expect to walk more in the future compared to the time of the survey. Whereas that was not the case for the city bus and the car, where we saw that the people are expected to use them more only to a very low extent, whereas the vast majority of respondents mentioned that they will use it either at the same level or they will use them less in the future. This is quite encouraging, especially for the car, where we saw that approximately 39% of people mention that they will use car less in the future compared to the time of the survey, which, just to remind you, was conducted in May 2023. In terms of the distribution of future intention of travel by trip purpose, again, for recreation, shopping, and personal reasons, we saw that the majority of respondents mentioned that they will travel in the future for the specific trip purpose at the same level, to the same extent compared to before, compared to the time of the survey. However, something which is quite interesting is that the respondents expect that they will travel less for educational purposes and for business purposes in the future. Just to clarify, when we are mentioning business purposes, we mean both the commuting to and from work and also the travel in the context of work, the business travel, in other words. This is quite interesting, and probably this captures the effect of teleworking, about the expectations of teleworking in the future, something that could be even more influential in the next slide, where we saw that in a country like Greece, where before the pandemic, actually there was no any possibility or any evidence of teleworking. As you will see, almost 90% of people before the pandemic never or rarely use teleworking as a mode of working. However, as expected during the pandemic, we saw that almost 8% of people telework to some extent. And now it means when the data was collected, we saw that almost 25% of people expect to telework at least a few days per week, which is something important and something that probably shows that there is a residual effect of the pandemic changes when it comes to the remote activities. In other words, we see that even the hybrid model of work, the partial teleworking, in other words, probably becomes a norm in the post-pandemic landscape in Greece. In order to identify associations between possible determinants of travel behavior and also remote activity patterns, we conducted a series of inferential statistical tests. As I mentioned before, we also conducted models, but in this presentation, we will be showing only the results of the inferential tests. Actually, we conducted Spearman's raw correlation and Kruskal-Walsh tests. Generally, we tried to see how the intended behavior in terms of travel, in terms of activity patterns, was affected by socio-demographic characteristics or attitudinal characteristics of the respondents. Generally, we conducted a lot of tests, approximately 60 or 70. However, very few of them were identified as statistically significant, which means that the p-value was less than 0.1 because we employed the level of significance equal to 90%. Just to provide, let's say, some indicative insights about the inferential statistics, we saw generally that the people that were traveling mostly by car before pandemic are more likely to travel by car after the pandemic. We saw that people that they were traveling more by bus and in general public transport in the past are less likely to travel by car in the future, which is quite intuitive, right? Because also it perhaps captures their access to a personal vehicle. And an interesting correlation is associated with who are more likely to telework in the future. We saw that younger participants, and particularly participants from low or medium income households, in other words, households that they had annual income less than 25,000 euros, were significantly more likely to use teleworking or any other kind of remote learning in the future. Probably they see teleworking as an opportunity to reduce their commuting time, but also to reduce their cost. And when we try to associate the travel habits with future intentions for teleworking, we didn't see a lot of results. We didn't identify a lot of statistically significant results. However, interestingly, we saw that people who expect to telework more in the future are more likely to work more. So the extra time which becomes available perhaps from the lack of the urban commuting, from the commuting time, probably is beneficial, is adding more time for working, either for commuting purposes or for recreational purposes, which is a quite interesting finding, especially for policy design, for policy implications. Overall, we saw that people, especially the younger strata of the population, because as I mentioned before, our survey mainly consisted of younger demographics. For these demographics, we saw a significant shift away from the private motorized means to public transport mainly, and at the second level to walking. We saw strong demographic effects in the sense that younger individuals are more open to use telework in the future, whereas lower and middle income households express a greater tendency for remote activities in the future. And quite interestingly, as I mentioned, in a country where teleworking was not at all a norm in the job market here, we saw that approximately for one-fourth of the sample in the city of Thessaloniki, the teleworking becomes slightly and gradually becomes a norm, at least in a hybrid model, in a hybrid format, where people can perform some remote activities at least a few days per week. What we can take out of this research and what we can do in the future, focusing on the limitation of the specific sample, as you saw, it was heavily skewed towards females and towards younger demographics. So future surveys perhaps could include in a more comprehensive way a broader representation of different age and gender groups. And given that our survey, our study was heavily focused on an urban area and quite densely populated urban area, like the one in the city of Thessaloniki, it would be important in the future to include more of the rural residents. We saw that there is a significant correlation between teleworking and walking. And actually, in another result that it was a bit more weak, so we didn't show it here, we saw that there is a tendency of younger demographics that telework more to use bicycle more frequently in the future. So because of these findings, we suggest that investment in pedestrian and bicycle infrastructure should be prioritized, and especially in a city like Thessaloniki, where it is a coastal city, so there are opportunities to integrate, let's say, active travel infrastructure. Actually, because there was also some questions in the survey that were open-ended, we saw that some people, they do not prefer to use public transport more in the future, even though they do not have any kind of risk perception any longer, because of systematic problems, structural problems of the public transport. So we saw that the lack of connection with smart technologies and smart communication was one of the barriers that, let's say, discourages them from using public transport. So we suggest a better enhancement, a more comprehensive enhancement of public transport with smart technologies. And of course, seeing that the hybrid model of working is an opportunity to increase active travel, in particular walking, it is a key recommendation of this study that hybrid working, especially in the private and the public sector, should be prioritized more in an effort to ease urban congestion. And this is particularly relevant and important for the city of Thessaloniki, where the travel delay times and the travel times are quite high because of the traffic congestions. Hope I did not waste so much of your time. Thank you very much for your attention. And of course, I'm happy to discuss any questions that you may have. Thank you.
So thank you Thank you, Dr. Fundas. I would like to ask, as usual, if from the audience in Istanbul there are any questions for after this presentation.
Yes, there is a question, and yes, we have here is wonderful because he's going to present right now.
Francesco Misso, Bivutec. Thank you very much for your presentation, very useful and very rich. And I'm dealing with projects about mobility in general and mobility trends, mainly in Italy, but not only. And it's a very important question, the changing in mobility trends with COVID pandemic. So it's clear your study is focused on the case study in Thessaloniki. And my question is, in your experience, in your opinion, how the peculiarities of Thessaloniki can affect the results of your survey? In other words, it's possible to find, I think so, but in your opinion, it's possible to find some general trends thanks to your experience in order to better understand also in other contexts and in other cities the mobility trends in the last years? Thank you.
Thank you very much for your question, and that is quite interesting and quite relevant to what we're doing, because as you very correctly mentioned, our study was tailored to the characteristics, to the travel characteristics, and also the urban planning characteristics of the city of Thessaloniki. Of course, generalizability challenges always exist, especially when we discuss about something which is based on online data, so it suffers from data-specific bias or self-selection bias. However, considering, let's say, the landscape of commuting in the city of Thessaloniki and the landscape of job market, I think that there are quite similarities with several cities, especially in the Mediterranean region, right? For example, Thessaloniki is a coastal city. It's a city which is densely populated. It's a city that, because of the significant density of the population and its urban planning, public transport is still has potential, has great potential to uptake, to take a greater share in terms of mode choice. And I think, given that you are also from Italy, I think this could be comparable to some cities like Bari or like Napoli, that perhaps they share similar challenges in terms of travel behavior, in terms of travel congestion. So I think a key takeaway here that perhaps could be comparable with other cities in the Mediterranean region is the association of teleworking with walking, right? And this is particularly important for coastal cities, where perhaps the urban planning policy initiatives perhaps can prioritize more shared space, especially considering also other active travel means like bicycles or like e-scooters and this kind of stuff. So considering that, we saw, and this is not only in our study, we also saw that the association of walking with teleworking has been also confirmed with data from Edinburgh in Scotland, where I was also personally involved, and also with data from even from the United States, which is even interesting, right? Especially in Washington, D.C. So given that this is something that seems to be quite established at the moment, in other words, the association of active travel and teleworking, I think that this finding is quite relevant for Mediterranean cities, coastal Mediterranean cities, where the integration of different kind of active travel infrastructure can perhaps serve as an opportunity to ease urban congestion. So yes, even though the findings are not generalizable, I think some of the associations are quite relevant for Mediterranean cities.
So thank you, Dr. Fontas. Are there any other questions or some comments about the... Some questions from home? Okay. If there are no other questions, I want to thank Dr. Fontas for his presentation. And we can proceed with the final presentation of this session. The authors of the next contribution are Sofia Nardoianni, Giuseppe Cappelli, and Mauro D'Apuzzo from University of Cassino in Southern Lazio, and Vittorio Nicoloso of University of Rome Tor Vergata. And the title of the next contribution is Research Trends in Pedestrian Safety, Topics, Methodologies, Techniques, and Data Insights. I want to invite Dr. Nardoianni to share her screen and to make the presentation. Thank you. The floor is yours.
Thank you. Can you see my screen?
Yes.
Okay, thank you. Good afternoon, everyone. I'm Sofia Nardoianni. I will present a work entitled Research Trends in Pedestrian Safety, Topics, Methodologies, Techniques, and Data Insight. Before starting, I want to thank my co-authors, Giuseppe Cappelli, Mauro D'Apuzzo, and Vittorio Nicolosi. In recent years, the number of accidents involving vulnerable road users, particularly pedestrians, has shown a warning upward trend, both in Europe and globally. This increase is evident from as shown multiple international reports and statistics. For example, the National Center for Statistics and Analysis has documented more than 12,000 deaths directly related to speeding in the USA alone during 2021, marking a significant public health concern. Similarly, the World Health Organization estimates that worldwide approximately 270,000 pedestrians lose their lives every year due to road traffic accidents. For this reason, it is important to understand the severity of injuries suffered by pedestrians as a result of the impact and what countermeasures should be taken to reduce these risks. Most serious injuries occur at the moment of impact with the vehicle, not in the subsequent fall. Severity depends on several factors: impact speed, vehicle geometry, bumper height, pedestrian age, position at the time of impact. For this reason, designers must take pedestrian interaction into account early in the vehicle design process, particularly for SUVs and commercial vehicles. For this purpose, for this study, we have analyzed and selected 93 scientific articles through Scopus, Web of Science, and Google Scholar. We have included studies using real data, simulations, or statistical models, excluding theoretical ones. The objective was to identify the most commonly used methodology for building vulnerability curves and suggest how to improve them. The methodologies used in the reviewed study fall into four main categories: numerical simulation, experimental data, real accident databases, and statistical analysis. Numerical simulation are the most common, followed by the real-world accident data, experimental testing, and statistical modeling. Each method has its strengths and limitations, but it is their integration that enables accurate construction of vulnerability curves. Integrating these approaches helps bridge existing gaps. Simulation allow for controlled, repeatable scenarios, while real accident data offer real-world complexity. Experimental data, though expensive, are essential for validating biomechanical models. Numerical simulation are a fundamental tool for analyzing the impact dynamics between pedestrians and vehicles, providing in-depth understanding of injury mechanism and associated risk factors. Through mechanical models and dedicated software such as PCCrash and Malaimo, it is possible to evaluate forces, acceleration, and tissue deformation during collisions, thereby improving the design of safety devices and regulations. For example, PCCrash is widely used for accident reconstruction, allowing the analysis of key parameters such as pedestrian height, collision angle, and pedestrian road friction, achieving accuracy with deviation of less than 10% compared to the real-world data. These models also help verify witness statements and validate reconstruction hypotheses, making biomechanics a crucial element in forensic analysis. The integration of advanced biomechanical models has also enabled studies on the effectiveness of active safety technologies like automatic emergency braking system, demonstrating that the timely intervention can significantly reduce impact speed and prevent a considerable portion of pedestrian accidents. Malaimo focuses on rate band deformation simulation, investigating material responses at different collision speeds and contributing to more accurate assessment of pedestrian injuries. The combined use of PC Crash and MADIMO allow for more precise identification of critical parameters, such as the point of contact and vehicle geometry, which influence injury severity, especially in taller vehicles like SUVs. In summary, numerical simulation represents an indispensable bridge between biomechanical theory and practical application, providing advanced tools for accident prevention and injury reduction among pedestrians. Experimental tests are crucial for validating injury severity curves and refining risk assessment in pedestrian vehicle collisions. Through crash tests with anthropomorphic test devices, biomechanical simulation, post-crash analysis, researchers improve theoretical models and identify critical injury thresholds, contributing to the development of safer vehicles and effective pedestrian protection measures. The main tools used in these tests are ATDS or crash test dummy and human cadavers, which allow measurement of acceleration and injury assessment at different impact speeds. However, it is important to highlight the significant differences between the biomechanical responses of dummy and real humans. For example, a study showed that in high-speed collision, cadavers exhibited multiple lower limb fractures and the differences in the head impact location compared to the average stupid dummies, emphasizing the limitation of ATDS in accurately replicating human biomechanics. Validated crash test results are essential to identify vehicle areas causing more severe head injuries to pedestrians, provide guidance for appropriate control measures in vehicle design. Moreover, autopsy and medical legal studies play a vital role in validating injury thresholds described in vulnerability curves. This data enable the definition of different injury types at specific impact speed and investigate how individual pedestrian characteristics influence crash outcomes. In summary, experimental tests combined with medical legal analysis are indispensable for improving understanding of impact dynamics and developing effective solutions to enhance pedestrian safety on roads. Reliable data sources are fundamental for analyzing accident characteristics, identifying risk factors, and developing effective pedestrian safety measures. Several comprehensive databases, including GDAS, CDAS, and so on, provide essential accident data that support in-depth analysis and targeting intervention to improve pedestrian protection. Beyond accident databases, hospital records offer valuable insight into injury patterns and contributing factors. Even data recording IDR data has also become a critical tool in accident analysis. By capturing precise information about vehicle speed and dynamics immediately before and after a collision, IDR data enhances the accuracy of post-crash speed estimates. A study demonstrated that IDR data provides more reliable speed estimates compared to the traditional accident reconstruction methods, improving the overall fidelity of crash analysis. Observational studies help further advance the understanding of injury mechanism in pedestrian vehicle collisions. For instance, a study conducted in Berlin showing that head injuries represent the primary cause of mortality in pedestrian accident, with a marked increase in risk when impact speed exceeds 14 km per hour. Complementing this, a study compared the dummy crash test results with real pedestrian accident data, revealing that dummy tests often underestimate injury severity and highlighting in this way the critical role of vehicle design in shaping injury patterns. In conclusion, the integration of diverse data sources from accident database to hospital records and vehicle IDRS, combined with observational and technological studies, form a robust foundation for improving pedestrian safety. Statistical analysis plays a crucial role in protecting pedestrian vulnerability in vehicle collision by identifying key injury patterns linked to variables such as impact speed, impact location on the body, and pedestrian characteristics. Through this analysis, researchers can develop models that estimate the probability and severity of injury in diverse crash scenarios, which in turn inform effective safety measures. Regression analysis is one of the main tools used to develop vulnerability curves that estimate injury risk. Logistic regression in particular is widely employed to quantify how vehicle front-end geometry affects pedestrian injury likelihood. Studies have shown that specific vehicle design elements like bumper height and depth significantly influence the risk of leg injuries, while the height of the hood's leading edge is correlated with femur and pelvis injuries. These insights offer valuable guidance for vehicle manufacturers aiming to minimize pedestrian injuries through design improvements. Among the variety of statistical methods used, analysis of variance ANOVA has also provided important insights. For example, one study demonstrated that elderly pedestrians and individuals with higher body mass index suffered the most severe injuries in collision. This finding stresses the importance of considering pedestrian demographic factors when assessing injury risks. Behind the distributional regression and ANOVA technique, more advanced statistical models, such as the partial proportional odds logit (PPO) model, have been developed to enhance injury severity prediction accuracy. Research by a study demonstrated that PPO models outperform standard logistic models by more precisely identifying influence factors with vehicle speed and pedestrian age emerging as the most critical. These underscore the value of applying sophisticated statistical methods to better understand and predict injury outcomes, ultimately contributing to more targeted and effective pedestrian safety intervention. In conclusion, statistical analysis remains a cornerstone in pedestrian safety research. By rigorously analyzing crash data with advanced models, we gain a clear understanding of injury mechanism and risk factors. Vulnerability curves are essential tools that allow us to identify the severity of injury sustained by users involved in vehicle impact by varying the most significant parameters. These curves, derived from statistical models, establish correlation between impact velocity and injury severity, enabling the prediction of collision outcomes based on key impact factors. In parallel, simulation using multi-body system and finite element models provide detailed biomechanical data related to injury risk. These computational methods offer deep insight into the mechanism of injury, contributing valuable information for design of targeted safety measures. Several studies focuses on defining injury threshold for critical parameters such as brain pressure and impact forces. Establishing these thresholds is fundamental for developing vehicular components and safety systems aimed at minimizing injury risks. Beyond the direct impact between vehicles and pedestrians, recent research has highlighted the significant role of secondary impacts, particularly injuries caused by ground contact. In addition to biomechanical and statistical approaches, innovative modeling techniques are emerging. For a novel model estimating impact speed based on windshield deflection, offering a new method for post-crash analysis and injury prediction. These computational advances highlighted the growing role of modeling in forcing crash reconstruction and injury assessment accuracy. Despite the significant progress in pedestrian safety research, several changes remain. Complexity of human biomechanics. The human body's biomechanical response to impacts is highly complex, requiring continuous refinement of simulation models to better replicate real human reaction to collision forces. Data availability. Access to comprehensive and high-quality accident data is crucial for developing reliable vulnerability curves and conducting meaningful research. Data gaps remaining a significant obstacle. Integration of human factor. Incorporating human behavior into simulations and statistical analysis is essential. Understanding how pedestrians and drivers behave in various situations will lead to more effective safety interventions. Advancement of safety system. Continued innovation in both activity and passive safety technologies is necessary to reduce pedestrian vehicle collision and mitigate injury severity. In conclusion, ongoing research and technological innovation remain vital in the quest to improve pedestrian safety. By combining biomechanical insight, statistical modeling, and behavioral understanding, we can develop smarter, safer vehicle designs and more effective safety measures, ultimately reducing injury risk and saving lives. The literature review highlights several key risk factors that significantly influence pedestrian vehicle collision. Vehicle speed is the primary determinant of injury severity, with higher speed exponentially increasing mortality risk. Vehicle design, especially front-end structure, also play a major role as taller and more rigid fronts tend to cause more severe injury, particularly in vulnerable groups. Pedestrian age is another crucial factor. Children and elderly are more likely to suffer serious injuries due to physical and cognitive limitations. Impact location, the vehicle geometry, future after injury type with windshield pillar impacts being especially dangerous. Environmental conditions such as poor lighting increase nightmare accident risk, and high pedestrian density correlates with more frequent crashes. Pedestrian behavior, including walking speed and direction, also influences crash outcomes, as does alcohol intoxication, which worsens injury severity and reduces survival chances. Finally, driver awareness and pedestrian visibility are critical, with many pedestrians remaining undetected until just 1 second before impact, revealing limitations in current detection system. In summary, improving pedestrian safety requires a comprehensive approach involving speed control, vehicle design improvements, prediction for vulnerable users, better environmental condition, behavior management, and enhanced driver awareness. Active safety systems like automatic emerging braking and the brake assistance system have proven effective in reducing vehicle impact speed and consequently pedestrian injury severity. AIB systems in particular have shown the potential to prevent a significant number of accidents, with study reporting reduction of up to 48% in simulation and 30% in real-world crashes. However, systems like BAS may shift impact points to stiffer vehicle parts, possibly altering injury patterns. Beyond the braking technology, innovations such as GNSS-based halters, pressure-based sensor, and external airbags and change early detection and injury mitigation, vehicle to pedestrian (VCP) communication also improve driver reaction times, but faces technical challenges like network congestion. In summary, the combination of braking system, advanced sensor, and VCP communication is key to improving pedestrian safety. Through future research is needed to address existing limitation. In conclusion, the review of 93 studies confirmed the importance of finite element modeling and multi-body simulation to predict collision and optimize vehicle design and the urban environment. Statistical models are essential tool for analyzing accident data and developing more effective mitigation measures. It is recognized that the risk of collision and the severity of injuries can be significantly reduced by technologies, including advanced driving assistance system and intelligent sensors. Some limitations remain, including the variability of experimental data, the difficulty of accurately modeling human behavior, and the need to test new methodologies in more diverse real-life scenarios. The integration of different approaches, such as combining numerical simulation with real data, needs to be further developed to improve the reliability of vulnerability curves. Future research should focus on advancing artificial intelligence application to improve the predictive capabilities of models and refine risk mitigation strategies. The creation of standardized global databases and the adoption of uniform international regulations will facilitate better application of the acquired knowledge. Furthermore, the review of literature articles concern vulnerability curves that describe the post-impact injury between pedestrian and vehicle. What we want to do is to free ourselves from the condition and evaluate vulnerability curves that also take into account other types of impact that involve vulnerable road user, such as pedestrian against a scooter, rider, or pedestrian against cyclist. Thank you for your attention.
Thank you, Dr. Nardoianni. So we are 8 minutes from next. We are next 8 minutes from next session. So I think we have time for only one question. So if someone from the audience or someone from the online audience have one.
No one from the audience.
Okay, not from the audience, not from online. So I want to thank Dr. Nardoianni for her presentation. We are 13 minutes later than the scheduled time. I want to thank all the authors, all the speakers, and all the people who attended the presentation, both online and in Istanbul. Just a reminder that at 16 of Eastern European time, there is the third session about mountain workshop. So thank you and good work to everyone.
Thank you all. Bye.
Thank you. Sorry, Professor Russo.
Yes.
I can send you an email to evaluation of the paper.
Perfect.
Okay, I send you by email the link. Thank you very much.
Thank you.
Okay, good morning to everyone. I am Gianni D'Angelo from University of Salerno, Italy, and I am the chair of this session. I would like to give you a warm welcome to the third edition of this workshop, the Cyber Intelligence and Application CIA, as a part of the International Conference on Computational Science and its Applications. I hope you are well. And also, I would like to extend my sincere thanks to you for sharing your work with us and for contributing to the quality of the conference program. I remark that any speaker has 15 minutes for presentation and 5 minutes for questions. Okay. And please, to avoid the interference, I suggest all other participants to turn off the microphone during the presentations. Okay. Well, we can start now. And first speaker is Tiziana Campisi, and the paper is Optimizing the Spatial and Digital Accessibility of Parcel Lockers, a Global Analysis of Adoption Dynamics by Tiziana Campisi, Bo Rus, sorry for my pronunciation, Socrates Basbus, Irina Di Ruocco. Okay.
Good afternoon, everyone. Can you see my screen?
Yes.
Okay, we can start introducing the main concept of our research. Our research starts considering some different literature review developments in accordance with the main concept of parcel locker in last mile delivery, especially during the last decades. We underline and we study some special factors such as population density, transport infrastructures, and also commercial proximity. And this research will try to discover through literature review something in terms of parcel locker allocation, and underline in the same way that less attention has been given on the last year on digital aspects, and to become a critical point for the effective deployment of these services. In general, parcel lockers are located in urban areas with a limited availability, especially in suburban or regional territorial regions. Some studies examine their social economic benefits and freight optimization, and some other studies underline some strategic spatial allocation and focus especially on user accessibility in terms of a scarce and fragmented location. These studies try to reply to different gap and lack, conducting a mixed approach. Firstly, we conduct a literature review using a Scopus database, identified 37 research papers with specific keywords. Secondly, we try to identify the main challenges in urban, rural, or not urban contexts in terms of accessibility, proximity, and digital use of parcel lockers. We can underline through a preliminary focus of research the lack on parcel locker allocation, especially in rural areas. And we can underline also that some studies cannot introduce something in terms of allocation analysis. And also some other research emphasize the need of the target awareness in order to promote also equitable adoption of these services. These research are a preliminary first step of the main research in order to underline for researcher, but also for city planner and logistic companies, some issues in order to determine better strategies and in order to decrease some economic disparities and introduce also something in terms of accessibility. The three main questions that was founded this research are related to the main funding from studies in terms of spatial location of the use of the parcel lockers in terms of accessibility and proximity. The second question is linked to the analysis of the main differences between urban and territorial contexts in terms of parcel lockers. And the third question, research question, is linked to the digital divide that could be determined a significant implication on the parcel locker and influenced the allocation of these parcel lockers. The literature review process consider this research step showed on this slide, in which we determine identification, screening, eligibility, and included steps. With the first, we discover some search objective and we determine the main keywords of research. On the second, determine the main website database, and we introduce the three main queries. After that, we select, considering title and abstract, including, excluding some of this research in terms of criteria. And after that, we selected, including on full text, replying to the three different research questions. The literature review protocol used by our research is underlined on this table, and the inclusion criteria are linked to the terms of parcel lockers, accessibility, digital technologies, but also proximity and spatial space location. The paper that are included on this research are all published in peer-reviewed journal and or in a reputable academic source. The article, the manuscripts that address territorial and digital perspective are considered in context of parcel locker adoption. Both empirical and theoretical studies that provide quantitative and qualitative research in terms of accessibility and digital inclusion are also examined, and the research discussing last mile delivery and also urban logistic and digital infrastructure for parcel locker adoption was considered. In terms of research or in terms of literature review research, we can observe this table in which we determine the main goal and the main perspective, including the principal keywords, including some space distribution in terms of region, in terms of European, eastern part of Europe, but also North America, Asia, and emerging markets. And we analyze also the main key findings and also the terms in terms of accessibility and proximity. In terms of digital access and digital divide, we are also focused the main research on this way, and we establish something also in terms of environmental sustainability, and also in terms of policy and research aspects. The same research was adopted in terms of singular cities, and we obtain this table in which we can observe some main capitals, some main cities that are examined in terms of accessibility and proximity, digital access, environmental sustainability, and also in terms of key gaps. In this way, we determine this table and we analyze firstly the parcel locker adoption and also the last mile delivery relative strategies, trying to focus on three main difference questions. We observed the literature review on the last 20 here, and we determine, and this research underline that there is regional disparities that define the not integration in terms of transport of freight at this moment, and also underline some lack in terms of digital accessibility and also in terms of relative sustainability factors. We underline through our research that Europe and also Asia underline some transit integrated parcel locker services. In opposite condition, North America and Australia, that are car-dependent networks, determine some problems in terms of accessibility and in terms of offset sustainability benefits. We underline through our research also that these emerging markets, especially in terms of e-commerce, determine some potential infrastructures, but underline also some digital barriers. And this problem are linked to the next step of our research, in which we need to integrate this approach. We can discover better this problem, and we can determine some strategies in terms of digital inclusion policies. In fact, I just underline on this graph that the future research can determine and try to be determine something better in terms of artificial intelligence linked to logistics, needs to determine something better in terms of a micro consolidation center, and determine primarily and better something in terms of mobile parcel lockers if we want to try to spread better strategies in terms of logistics, especially in terms of efficiency and sustainability on these fields. And also another consideration made by this literature review is that it is important to understand better the consumer behavior in order to describe some long-term policy impacts that could be crucial, especially if we want to study some scalable and last mile solution, and could be balanced better the spatial efficiency and also the digital equity in this context. I want to thanks for your attention, and I completed to share my research.
Thank you very much. Congratulations for your presentation and the research field. Okay, are there questions? Okay, I have just a curiosity. Why is it important to investigate parcel lockers distribution in a non-urban area in contrast with the urban areas?
Okay, our research start considering something in terms of sustainability and sustainable mobility. If you want to reduce the use of private car, if you want to spread better something in terms of different transport modes for passenger or both for passenger and freight, it is important to include and discover not only the main city center, but also the weak demand areas where people needs of some services. and the lack of literature review in this context try to underline this necessity.
Have you thinking in which way to use the artificial intelligence in this field?
I'm trying to discover better if we can determine the main factor, the main variables that could be determine the behavior of the user, and we can use in this way in order to research and discover better the user demands. On the same way, we can also try to use the artificial intelligence in terms of correct localization of the pickup points and also the parcel lockers. Both demand and supply in freight transport could be determine a good relationship with artificial intelligence also.
Okay, many thanks for your presentation. Any questions? No? Okay, we can move on the next talker. Thank you, Dr. Campisi. The next paper is Risk Management in Transportation Systems, Architectural Framework for a Technologies Driving Disaster Management System, by Giulia Martina, Vittorio Astarita, Sina Sciaffi, and Giuseppe Guido. Okay, the speaker is Dr. Martino? No.
Yeah, Giulia Martino. Yeah, I'm
Giulia.
here.
Okay, thank you very much.
Okay.
You have the floor.
Yeah, I show my mirror. Okay. Okay, can you see?
No, okay. Yes, now yes.
Now yes?
Yes,
okay.
You can start, please.
Okay, good afternoon, everybody. I'm Giulia Martino from University of Calabria, and today I will explain you our research titled Risk Reduction in Emergency Evacuation through Innovative Mobile Applications, a study on user trust and behavior. Our cities are growing larger and hosting more and more people. However, it's not just the population that has increased. The frequency and the intensity of extreme weather events caused by climate change have also risen. For this reason, it is essential to have effective evacuation plan in densely populated areas. These are some of alert systems around the world. Many offer various and important features such as geolocation, information sharing, and interactive maps. But these technologies have some limitations, such as the lack of real-time information, interactive or socially shared maps, difficulty reaching tourists or occasional visitors, and personalized evacuation routes. But
sorry, but the slides are blocked.
Yeah.
On the first slide.
Okay, just one moment.
Maybe you
okay,
have
now?
to monitor.
No, I have just one monitor.
No.
Okay, one moment. I'll try again. Okay, can you see now?
Yes, now it's okay.
Okay, this was the second one. And this is the tables. Can you see the tables with alert systems?
No, I don't see the next slide. The presentation is blocked. Okay, now yes, okay.
Okay, so maybe it's better if I don't put the presentation way, because I think it doesn't work. Maybe it's better if I select this visualization. Are you agree with me?
Yes.
Do you agree? Okay. This is the tables that I was showing first. The tables shows some of the alert system around the world. Many offer various and important features such as geolocation, information sharing, and interactive maps. But these technologies have some limitations, such as the lack of real-time information, interactive or socially shared maps, difficulty reaching tourists or occasional visitors, personalized evacuation routes. Please tell me if you can see the slides. Okay. It was precisely these limitations that inspired the idea of developing software to utilize data collected by IoT devices in our cities, such as cameras or satellites. This data will be analyzed using artificial intelligence and machine learning technique to identify safe routes for guiding users. But the question is, would users follow the information provided by an app? Okay. So, to investigate this question, an experiment was conducted in the city of Rende in southern Italy. Specifically, the experiment focused on the industrial area of Rende, where the Crati River is located. The scenario involves simulating the collapse of Crati Bridge following a flood. This will cause a road closure, and the goal is to assess users' willingness to follow the app's directions. The pilot project was conducted with employees of a local company, and this is the company. I don't know if you can see the arrow. The workers were told that following a flood, they must evacuate to an assembly point designated by the civil protection authorities, and this is the assembly point. They know that there are two possible routes to reach the assembly point. Route A, which is longer, and Route B, which is shorter. What they don't know is that Route B has been blocked due to the collapse of the Crati Bridge, so taking that path would result in wasted time. They are then asked the following question. Knowing that Route B is shorter, would you take Route A if the app indicated it as the safest option? Overall, the questionnaire aimed to assess knowledge of the routes to the assembly point, trust in the app's guidance, and preference between reaching the assembly point or reuniting with family. This particular question was included as a test to assess the validity of the experiment. The goal was to determine whether users were responding honestly. If everyone had answered that they would prefer reaching the assembly point, the experiment could reasonably have been considered unreliable. Instead, the results aligned with expected human behavior. In fact, about 60% would prefer to reunite with their family rather than go to the assembly point. And over 90% of respondents would follow the app's instruction in case of an emergency. These results also highlight the importance of training. In fact, it is reasonable to conclude that such highly positive outcomes are also due to the initial training phase. In conclusion, alert systems are crucial for public safety but require improvements. The RISC project offers an innovative approach with personalized evacuation routes. Users' trust in the app depends on training and information, and it is essential to consider human and cultural factors in emergency planning. For the future, our advice is a continuous technological evolution of alerting systems, a large-scale implementation and testing for the RISC project, and more. For a future developments could explore the integration of satellite internet to ensure connectivity and real-time emergency alerts even in remote and disaster-affected areas with limited traditional network coverage. My presentation is concluded, and thank you for your attention.
Thank you for your presentation, Dr. Martino. Are there questions? Okay, I have just a curiosity. Actually, are there some pilot projects that is capable to test this framework?
Yeah, in another work, we tested this by using a simulation software. We developed this simulation software that is called Tritone, and we put all the data in the software and we simulated the behavior of users.
Okay, thank you. But how does the system can use artificial intelligence to improve forecasting and also the decision-making process during disasters?
The systems as as planned the systems is incorporated the artificial intelligence that can reliable and the information provided by IoT devices and some other devices in our cities.
But the artificial intelligence software is mounted on the smartphone.
It's mounted on the smartphone, on the software that is installed on the smartphone.
Okay, thank you very much. Are there any questions? No. Okay, we can move on the next presentation. The title of the next presentation is Finding Sustainable Clusters in Supply Chains Dynamics by Graph Partitioning by Raffaele D'Ambrosio, Stefano Di Giovacchino, and Carmela Scalone. Okay, the speaker is Dr. Scalone. Dr. Scalone, now you have the call.
Hello, good morning. Can you see my screen?
No, no.
Okay. Can you see now?
We look your screen.
Yeah,
but not
now
your
I should.
presentation.
Yeah.
Okay.
Just a second. Now can you see my presentation?
Perfect. Now is okay.
Thank you. So good morning and thank you for the introduction. So this work is a part of a mathematics project for sustainable innovation. And today we will talk about essentially the possibility to use tool of applied mathematics such as graph theory and algorithms to clustering graphs in order to detect communities which are meaningful in terms of CO2 emissions in supply chains. So the program of the presentation is the following. We will start with just the definition of a supply chain in general. Then we will see how a graph can be associated to a supply chain. And then we will see what is essentially the algorithm that we use and the motivation to use a perturbation-like algorithm to study the CO2 emission clusterings. So let's go to the definition of a supply chain. So we have a supply chain is the entire system of producing and delivering a product. So from the very beginning stage, we have the production and then the delivery to the user. Associated the data of a supply chain are essentially collected in the so-called input-output tables. We have a matrix A whose element ij represent the units of input I needed to produce 1 unit of input j. So we have the representation essentially of interdependencies among economic sectors. Then in terms of A, this matrix, which is in the input-output table of the supply chain, we can define the so-called Leontief inverse. And then, essentially, for each commodity, we have an energy-intensive vector. And for any if we call K the commodity that for which we are considering the supply chain, for instance, automobiles, this will be our case of study. We have the so-called final demand vector, which is made up by the product of the Leontief inverse times the demand vector. And then we can consider the vector of the total energy requirement, and starting from this Q vector, we can define the so-called matrix Q, which is essentially for any commodity K, the matrix that define the total factor input, any element ij of the matrix Q represent the total factor input of commodity J to produce 1 unit of the commodity I to produce one input of commodity J. This means that in the matrix Q we have all the information of the total factor input. Of course, this Q is referred to a commodity K. So we consider a commodity, automobiles, for example, and then we can construct this Q. When we symmetrize, we can construct essentially the adjacency matrix of a graph. So with this matrix, which is the weighted adjacency matrix of the graph, we can consider essentially the graph associated to the supply chain. So in this case, supply chain, we can associate a graph, and the nodes represent commodities of industrial sectors. Of course, all this stuff is related to a special selected commodity, for instance, automobiles, just to make an example. And the edges represent input flows, which are derived from the output tables. We construct the matrix Q, then the Q stars, and so we have the graph. So what is the meaning of clustering? With clustering, we consider a partition of the nodes, and the idea of clustering is that essentially we consider any of this group of nodes are densely connected. And so in general, so when we have that, in our case, we will consider we will consider clusters, and in any group we will have the same, not the same, but very similar, very connected amount of emissions. So this will be, in general, clustering is essentially partition the set of vertices. In our case, with this partition is particularly meaningful in terms of CO2 emissions. So this is the mathematical formulation in general of clustering, and essentially we have, essentially the idea is to detect this community of nodes. So remember that nodes in our graph supply chain are sectors or industries or producers. And so once we have detected these communities in terms of emission of CO2, be able to be useful in terms of policies to environmental sustainability. So we have existing method for graph clusterings, filter partitioning. We consider essentially we consider the algebraic connectivity, the second smallest eigenvalue of the Laplacian matrix, and then we cluster based on the sign of the entries in the corresponding eigenvector. Or it is possible also to find the non-negative matrix factorization of the weight matrix. These are very standard, these are very classical, but in the literature we prefer to do these cases of study with a perturbative type algorithm. Essentially, the idea is the following. We aim to find the smallest perturbation of the weight matrix such that we have that the second smallest eigenvalue of the corresponding Laplacian is equal to 0. When the Fiedler eigenvalue lambda 2 is equal to 0, this means that the graph is disconnected. So essentially, and in this way we can consider the two communities, and we can of course hierarchically apply this kind of algorithm, and so we proceed as follow. This is the summary of the algorithm. Essentially, we have for any fixed size of the perturbation, we have a perturbation of norm 1, and for any epsilon, the norm of the perturbation, we find the best, so the minimizer of lambda 2. And then this is a two-level algorithm. We find the minimum epsilon such that lambda 2 is equal to 0. So this is the summary of the algorithm. The key tool is a gradient system for the perturbation I. So essentially, for any fixed size of epsilon, the size of the perturbation, we are able to find the optimal E. And then, in the second level of the algorithm, we optimize with respect to epsilon and find the epsilon such that the second eigenvalue of the corresponding Laplacian is equal to 0. So we partition, the partitioning is made up with a perturbation algorithm of the weighted matrix and consequently of the graph Laplacian. So we consider, so why in these cases can be a good idea to use a perturbation-based algorithm, because this kind of algorithm is very suited for including other constraints. For instance, in the example that I will show you in a moment, so first of all, it is possible to consider structured perturbations. So to perturb the weighted matrix with the same pattern of the starting matrix W. What does it mean in terms of the supply chain of the graph? That with the perturbation, we are not adding interactions that are not in the starting graph. Or if we want to see essentially the impact of adding interactions, we can choose the pattern, and so considering also other structures in the perturbation, and so be able to do interesting analysis in terms of, for instance, freezing some sectors, for instance, plastic or others, in the construction of our commodity, and so see the perturbation just with respect to others. And also it is also possible via a penalization, since we are considering an optimization problem, it is also possible to add the membership constraints. What does it mean? So if we want that to constrain, if possible, to constrain two sectors or two industries to stay in the same cluster for some reason that comes from application. So as this is the idea of and why we choose to do this kind of analysis, the perturbative algorithm. So let's go to a numerical experiment. So it is possible, we download essentially the data set of Japanese input-output tables of the year 2000. And this focus on automobile industry. So we have 393 industrial sectors, and we have essentially this data set was very good for our application, because we have all the data in terms of CO2 emissions and what we need. In this kind, to do this kind of applications, sometimes is the lack of data that makes the analysis a bit complicated. But this data set was very nice. And so after pre-processing the matrix, because when we take the matrix, we found that there are several, so we focus on the main connected component of the graph because there are some isolated nodes. And so we considered our experiment working with a perturbation which are pattern preserving. So in this particular experiment, we are not altering the pattern of the weighted matrix, but as I told you before, it is possible also to see other pattern to essentially see the impact of other scenarios. In this case, we find 15 clusters in terms of similar CO2 impacts, and once we the algorithm give us the clusters, we measure essentially the total input of each cluster, essentially summing the entries of the weights which are in the cluster. In this case, the greatest connected component was quite big, so it is a bit complicated to visualize the experiments, but we find 3 most impactful clusters, and these are the result in terms of tons of CO2 emissions. And of course, the corresponding sectors are for these 3 clusters are the ones on which it is important to act in terms of CO2 emission reductions. So, of course, we can consider also other scenarios. The importance is to have data available, and so this is an issue, this is an important point. And so I think I can stop my presentation, and thank you very much.
Okay, thank you, Dr. Scalone. Are there questions? I have just a curiosity. Does the algorithm solve some specific optimization problem?
Yeah.
Yes.
We are essentially the optimization problem. We minimize the second smallest eigenvalue of the Laplacian of the corresponding perturbed matrix. This is the code, and it is possible to define a gradient system because there are formulas to define that give us the derivative of the eigenvalue, and so we construct the gradient system in terms of the perturbation.
Does the algorithm could be replaced by some artificial intelligence-based technique? Do you think? What do you think?
I solve it with the mathematics. To be honest, I don't know.
Okay, I want to suggest you my research that is able to solve constraint optimization problem. Its name is GGA. GGA. Yes. If you want, I can share the link. Okay.
Okay, thank you. But this is unconstrained.
Not constraints, but it is possible to solve also not constrained.
Okay, thank you.
Okay, thank you very much for your presentation and congratulations for your work. Now we can move on the next speaker. The title is Cutting-Edge Malware Detection in Healthcare, Leveraging Cascaded AlexNet Model by Sania Akhtar, Mohammed Hanif, Mohammed Waqas Arshad, and Farayal Farouk. Okay. Is there the speaker? No? There is no speaker for this work? Okay. There are no other speakers, so thank you to all authors for their interesting contribution and their brilliant presentations. I hope you found this workshop a good container of ideas that have stimulated new research and application. And now I invite you to join the next section. Okay, thank you very much for to all. And now I can declare close this workshop. Goodbye to everyone. Goodbye.